Space, the final frontier. But before we can truly explore the cosmos, we must first conquer its dangers. Beyond the safety of Earth, astronauts face threats that could end a mission, or even their lives. From deadly cosmic radiation to the psychological toll of isolation, space travel is far from easy. Today we're diving into the harsh realities of deep space travel and what's being done to keep astronauts safe. Let's start with one of the most invisible yet deadly dangers, radiation. Here on Earth, our atmosphere and magnetic field shield us from harmful cosmic rays and solar radiation. But in deep space, astronauts are exposed to high-energy particles from the sun and distant galaxies. A sudden burst of solar radiation, like a coronal mass ejection, could deliver a lethal dose of radiation in minutes. Without proper shielding, prolonged exposure can cause cancer, DNA damage, and even cognitive decline, something scientists call space brain. To combat this, spacecraft and spacesuits are designed with radiation-resistant materials. Future missions to Mars may even require astronauts to build shelters using Martian soil to block radiation. Imagine being confined in a small space for months or even years, cut off from Earth. No fresh air, no real-time conversations with loved ones, and the same handful of people around you every day. Isolation is one of the biggest psychological challenges of space travel. NASA and other space agencies run isolation experiments on Earth to study how people cope. Some take place in remote locations like Antarctica, while others involve simulated Mars bases. To stay mentally strong, astronauts exercise daily, keep busy with tasks, and use technology like virtual reality to simulate natural environments. But nothing can truly replace human contact, which is why psychological support is critical for long-term missions. Zero gravity might look fun, but it wreaks havoc on the human body. On Earth, our bones and muscles stay strong thanks to gravity. But in space, without resistance, astronauts experience muscle atrophy and bone loss. Astronauts can lose up to 1% of their bone mass per month. That's why they follow strict exercise routines, up to 2 hours a day, to counteract these effects. Microgravity also affects blood flow, causing a condition known as space anemia. Some astronauts even experience vision problems as fluid shifts in their bodies, putting pressure on the optic nerve. In the future, artificial gravity systems might help mitigate these issues. But for now, astronauts must rely on rigorous training and research. Space is not empty. It's filled with tiny meteoroids and space junk traveling at incredible speeds. Even a small piece of debris moving at 17,000 miles per hour can punch through a spacecraft. To protect astronauts, spacecraft have reinforced shielding. The International Space Station is equipped with Whipple shields, multiple layers of protection that absorb impacts. But it's not just external threats. Equipment failures can be just as dangerous. A malfunctioning oxygen system or a fire on board could be catastrophic. That's why astronauts train extensively in handling emergencies. With plans to send humans to Mars, the risks of deep space travel become even greater. A round trip to Mars could take over 2 years, with no immediate help from Earth if something goes wrong. With plans to send humans to Mars, the risks of deep space travel become even greater. A round trip to Mars could take over 2 years, with no immediate help from Earth if something goes wrong. Space travel is dangerous, but it's also the key to our future. The risks are high, but so are the rewards. By pushing the limits of technology and human endurance, we're not just surviving in space, we're learning how to thrive beyond Earth. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell for more space exploration content. Until next time, keep looking up.